Today's daily code problem of the day is maximum erasure value number 1695. For this problem, we're given an array of positive integers called nums and want to erase a subarray containing only unique elements. So the score we get by erasing a subarray is equal to the sum of all of its elements. Basically, we want to return the maximum score of a subarray that is only of unique elements. So for example, if we look here at example 1, and by the way, subarray has to be contiguous. So you can't say like 4, 2, 4, get rid of that 4 and go 5. It has to be in a row. So our longest continuous or contiguous subarray would be 2, 4, 5, 6 with only unique elements. So we're going to use a hash map for this problem and a sliding window, and we're going to use the hash map to keep track of what elements are in our subarray, and a sliding window to constantly update our sum. So for this problem, first thing we're going to do is initialize two variables that are going to be our max sum, which we will start up as our nums of 0, and our integer sum, which will be also nums of 0. These will just help us keep track of the current running sum and our current max sum to compare it to. We'll also have a hash map, which will be storing integers with integers, basically just keeping track of if a value was already found in our subarray or not. We could call it our map, and that is a new hash map. So this is simply going to keep track of what values have been found in our subarray so far, and if we need to get rid of that value before we can add it again. We'll also need to map.put our nums of 0, and we'll update its count to 1. Now we're going to also initiate an integer L, which will be our left pointer, and then integer R, which will be our right pointer. And because we have already initialized our map and our sums using nums of 0, we can automatically set R to equal our first new index. Now we're going to use two while loops. The first while loop is going to basically go through each R position. So we're going to move our R value, or our right pointer. And then the inner while loop will move the left pointer. And that will only happen when we find a duplicate number. So first, we're going to set up our right pointer mover. So while true, we're going to check if our right pointer value is equal to the nums.length. We're going to automatically break because there is not going to be a value at nums of R, so we can automatically move on. Then we'll check if our map.contains the key of the value at nums of R. Basically, this is checking, does nums of R already exist in our subarray? Then we want to increment our left pointer to get rid of it. So for example, if our left, hold on, I have my pen. Okay, so if we have our left pointer here, let's get rid of the highlighter. So if we have our left pointer here and our right pointer here, we're going to first add this to our hash map, add 2 to our hash map, and then we're going to increment R. So now R is pointing at this 4. Well, our hash map will say, hey, we already have a 4 in it. So what we're going to do is we're going to increment our left pointer until we find that 4. So it's going to automatically be on that 4, but if it wasn't, we will increment it until we find the 4, get rid of it from our map, and then add this one. So that way, we only have unique elements in our map/subarray. So for this, we're going to need a new while loop. So while true again, this is where we're going to increment our left pointer. If our nums of left pointer is equal to nums of right pointer, then we have found the culprit. We have found the duplicate. So we're going to get rid of this one by simply incrementing our left pointer one more time. We don't need to add it to our sum because we already added our right value, or we're going to add our right value. And we do not need to destroy it from our map because we are already going to have to add it back with our right pointer again. So we simply just need to increment our left pointer, and then we are going to break out of this loop. Otherwise, if our nums of left pointer is not equal to our nums of right pointer, that means we're going to need to increment the left pointer until we find the duplicate. So our sum will minus equal whatever nums of L is, or nums of our left pointer is, because that is not our duplicate. And we will also remove it from our map because we're only going to ever have one occurrence of a number in the map, we don't need to worry about incrementing or removing any of the second numbers. For example, we could just remove the entire key. Then we're going to increment L as well. So we're going to move on to the next value and check again, is nums of L equal to nums of R? And we'll continue to check until we break. So if that's only if the map contains our key already. If the map doesn't already contain our key, we're going to want to put that value into our map and add it to our sum. So we're going to map.put our nums of the right pointer, and we will automatically set it to 1 because there's one occurrence. Then we'll also add it to our sum. So sum will plus equal our nums of R. And then we will update our max sum. So we added a new value to our sum. We're going to say, hey, is this a new max sum? So math.max, max sum, and sum. Basically, we will check if we had to remove anything, and then we add our new right pointer to our sum. Is it a new value or is it smaller? Now, either way, whether the map did contain our key or the map did not contain our key, we're going to want to increment R so we can move on to the next value. So R will plus plus. And that is it. So if we return our max sum, this should hopefully pass our test cases and pass all solutions. Very quickly, I might add. So thank you, and follow for more daily LeetCode solutions.